This is Note-Taking Guide 2.5, Dividing Complex Numbers. In order to divide complex numbers, we actually do something called multiply by the conjugate, so we need to decide what a conjugate number is. If we have a real and imaginary number added together for a complex number, its conjugate is the same real number, and then we just change the sign on the imaginary part. See how it was plus I? Now it's minus I. So we change the sign on the imaginary part, leave the real part the same. So a negative 3 plus 7i, the negative 3 on the real part stays the same, and the plus 7i becomes minus 7i. The conjugate of 6 minus 4i becomes 6 plus 4i. Again, the real stays the same sign, the imaginary changes. So at the bottom of the note-taking guide, there's a couple of examples that look like this, where it just says to state the conjugate. If you have 5 minus 2i, your conjugate is going to be 5 plus 2i. Leave the sign alone on the real, change the sign on the imaginary. If you have a negative 7i, the real part would be 0 out front here. We're just going to leave it 0, and we're going to change the sign on the imaginary part for a positive 7i for the conjugate. Just as a little reminder, if they put it in the wrong order, say you have 7i minus 2, and they want you to find the conjugate of that. Again, you're leaving the real part alone. The real part is negative 2. The imaginary part is 7i, so you would change the sign on it to be a minus 7i. So now that we know how to do that, what we're going to do is multiply by the conjugate in order to divide. So the 2i down here, its conjugate would be a negative 2i. If we multiply the bottom by the conjugate, we also have to multiply the top by the conjugate. So top times top would be 5 times a negative 2i, which is a negative 10i. And then on the bottom, 2i times a negative 2i would be a negative 4i squared. If you remember last note-taking guide, we reminded you that every time you see an I squared, you're going to change it to a negative 1. So you'll have a negative 4 times negative 1 on the bottom here, which will be a positive 4. And on the top, we'll have a negative 10i. This would be okay for your answer, but this does actually reduce. Both the top number, negative 10, and the bottom number here are divisible by 2. So I'm going to divide that by 2 and just write my answer with that division by 2 done. So negative 10 divided by 2 is a negative 5, and 4 divided by 2 is 2. So this is my answer in simplified form. This next problem, if we're multiplying by the conjugate, we're going to find the conjugate on the bottom, which is a positive 3i. If we multiply the bottom by the conjugate, we also multiply the top by the conjugate. So we're going to multiply the top by a positive 3i also. So this becomes a distributive property. 3 times 3i is 9i. And then 4i times 3i would be plus 12i squared. We'll do the bottom multiplying now, so this will be a minus 9i squared. Again, we have that rule that says every time we see an I squared, we're going to change that to a negative 1. So this right here becomes a negative 1. So on the top, we'll have 9 minus 12i. Oh, I'm sorry, 9i minus 12. I said that backwards. And then on the bottom, this becomes a negative 1 again right here. So we have 9 on the bottom because a negative 9 times a positive 9. A negative 9 times a negative 1 is a positive 9. And I could leave it here and be pretty much done, but if I notice all of my numbers here are all divisible by 3, so I want to divide that 3 out. 9i divided by 3 would be 3i, 12 divided by 3 would be 4, and 9 divided by 3 on the bottom would be 3. So this is really my simplified answer.